Thank you so much, John, and thanks so much for having me here. It's an honor. And my name is Kevin, and today I will be talking about our work at Takachar, and specifically what we learned from deploying kind of fleet of reactors and MRV development. And I'm glad I'm here last because I think you've already heard about the concept of decentralized deployment and fleets. So I will just be building on these and specifically focusing on the kind of what it takes to kind of design a procedure with local communities. So the outline is I will just be first talking about a little bit about Takachar and our work in case you're not familiar. If you are, feel free to sleep through that. But wake up in the second part because there'll be a quiz on the third part. So the premise of our work is that biomass is loose, wet, and bulky, which makes them very difficult and expensive to collect and transport to a centralized place. And as such, many rural communities are often shut out from the benefits of the bioeconomy, and their only recourse is to burn their residues in open air, which not only creates significant pollution, but can exacerbate catastrophic wildfires. So what we're developing are small-scale, low-cost portable systems that can latch onto the back of tractors and pickup trucks. And these are 1 ton per hour units. Somebody asked about the oil drum that has since then been replaced with a self-dumping hopper because we don't want to be emptying that drum every 5 minutes. And this is Pure certified, and we have a fleet operating in North America. Actually, I think we have 17 units right now, not only in North America, but also India and Kenya. So under diverse conditions, so we've worked with wood chips, we've worked with of different hardwood and softwood. We've worked with coconut shells, almond shells, walnut shells, rice husk, bagasse, pellets, and long things like straws and rice straws and wheat straws. These are how some of them look like. The design is the same, but a lot of the times they have been contextualized to our local end user requirements. The one in Canada, for example, the local client insisted on having that containerized, right? So it looks slightly different depending on the location. And part A is essentially in India, where there's a group of 4 reactors operated by one team in parallel. So a lot of the cases, the focus is on agriculture, so turning kind of excess post-harvest residues. And the output in this case, especially in places like Kenya, India, is a biochar-based fertilizer blend that's government certified and at the same price that the farmers are paying per hectare per season compared to their traditional chemical fertilizers improve their yields on average 27% and net income by 50%. And here's what some of them have to say. Oops.
If they are not started using it, they should start now.
Tangu ni Joseph Organic na after kuitumia ile mazao nilitumia ifanya kunikuza nikakuwa nimeinuka kuliko pali nilikuwa.
Zilenya na kuma mogonda. 1 idio gakoro ngoro ndina irio cia kuigana ku mucere. Number 2 uria woneka excess ngendia
Beyond agriculture, we've also been doing work along the West Coast around forestry. So this is a small unit that we deployed in Canada. And as you can see, compared to the burn pile that's behind it, and it has worked through winter conditions like below 0 Fahrenheit. So next, I'm going to talk more, focus on the monitoring, reporting, and verification part. You probably have heard from the previous sessions already, but I'm going to go into more of the nitty-gritty details and also some of the messy human factors that's involved when you actually have people interacting with the MRV system, right, and what we have learned from that process. So MRV is necessary because, as you probably have heard, it's a way for quantifying, tracking, validating greenhouse gas emissions so that you can report the data transparently, and that's useful if you want to certify the biochar for carbon credits, which is what we do. We are certified through Bureau, and we have worked with that and also have experience with isometric. So with monitoring, reporting, verification, there are a host of data that's required of the reactor. If you are working on a large-scale centralized facility, that's a large project. Often case, it's easier done that way because you can kind of instrument the data, and then you have a consistent source of kind of offtake contract for input and output, so you can normally use that to prove that the materials are flowing. But if you have a decentralized fleet of reactors, that gets pretty complicated. The reactor is something that that data is something we can still automate, right? So we can put thermocouples in there, we can put sort of scales, right? And then we can upload that data to the cloud that then goes to our server and the carbon registry. But for the rest of it, like receipts, electricity bills, water bills, and use application and proof that you are putting it in the soil, those are things which, if you are working with like 15,000 farmers, which is what we do, then it becomes unwieldy and can be expensive relative to the cost of kind of, relative to the kind of the carbon credit, meaning that the barrier for getting small project through the traditional kind of carbon registry could be much higher because of those stringent data requirements, and then you're doing this for small quantities of carbon credits, normally between like 1,000 plus tons. So what we've been trying to do is to define requirements with our end user community, right, such that we can develop a process that can work the fleet that's decentralized, that's language agnostic. It doesn't depend on what language a field worker is speaking. And some of them may even be semi-literate and may have different cultural expectations. And specifically, it's context dependent, meaning that from reactor to reactor, the biomass is going to change, which means the LCA is also going to change, right? So we have to account for all of that in the MRV process. And finally, it's verifiable, meaning that the data coming in still has to be trusted enough that it can pass the third-party audit from VVB audit for Pure Earth or other registries. So the first step that we do is kind of a co-design process with the communities, because what we realize is that different communities have different requirements. Some of them even have different cultural perceptions of what climate change or carbon credits means in their own cultural narrative, right? So those are some of the things we kind of have to work with them through a lot of participatory design workshops to understand what are the important things and how do we phrase kind of MRV process within that community. And once we have that, we came up with like a first iteration. So this was done with our partner Carbon Pilot, which I think is now called Valorize Systems. So they implemented an app with us, and they were gracious enough to kind of allow us to ask them to make changes depending on what we find in the field with trialing with end users. So that they can kind of take picture of their receipts or bills or pictures of biochar or pictures of moisture readouts and really get that uploaded in a way that's kind of seamless for them. So through that process, we did run into various challenges, unexpected. Some is kind of unexpected. So the next part is kind of a quiz. So for you to kind of maybe work through with me kind of to understand what are some of those challenges. So this is the first case, and I'm going to ask you to maybe explain a possible reason. So we had a case where in the initial phase, we were testing the moisture content in the biochar, right? So essentially a worker would go, and back then it was just a very simple and probably inaccurate moisture probe, and probe that into different parts of the biochar and essentially take 10 readouts and averaging that and reporting that. And for a particular site, we were consistently getting 100% plus moisture content for the biochar. So who wants to guess what might have happened here if you are just kind of receiving the data? Yeah? Okay, so it could be the sensor, right? We did look at a sensor. It was fine, actually. So one hint is that this same worker back then was also tasked not just with the moisture, but also back then everything was manual, so we didn't have a electronic scale yet. So the person would weigh the different buckets of biomass and dump that in as they come in, and they would tally that up at the very end. So this person got really good at addition.
So they're adding across.
They were adding the moisture instead of averaging it, right? It seems like a stupid thing, after fact, but those things happen, right? And so what are some of the fixes, I guess, we could make in this case to the system? Yeah, exactly. So we can automate it. We can even have them take pictures so they don't have to do the math, right? So those are some, we have confusions over units. Many things like that happened if you're talking about buckets or kg or things. So those are the things which we try to work through in our MRV process. The next one is a fun one, I guess. So in this case, after a few months of manual kind of weight measurement, we did eventually upgrade to kind of electronic scale, right? So what happens is that laborers would take their biomass, kind of before they load it into the hopper, they will put on a scale, right? And then that will kind of send the weight automatically through the cloud. And then what we get is kind of this graph. It's the time series. So x-axis is like, I'm assuming those are minutes. And on the y-axis, these are the weights that are registered by the scale. So on the normal operations, what happens is that you will see these peaks, right? That's when, each one of these distinct peak is when a laborer put a bucket on the scale, and then you get a peak, and then you add those up, and you get your input biomass and output biochar accumulation over time. So let's work through some abnormal cases, and maybe you can tell me what's wrong with them. The first one, hopefully, is pretty easy. So we have this baseline is here, I guess. So I guess compared to this, so what do you think caused that? Yeah, so somebody forgot to tear the scale. It's easy, right? We teach them to do that, but sometimes people still forget, right? Even after training. So fortunately, that's a relatively easy problem to overcome, right? You can adjust for that in your data structure. So next one is sometimes we see these. So like we have, let me see. These are the regular kind of loads, but sometimes we have these loads that are massive. That's like almost twice as much, which is really confusing because the bucket is the same volume. How can you have twice the weight? Okay, that's a good guess. That's possible. So it could be somebody, and well, entering twice wouldn't be possible because they put the bucket on the scale, right? So
they weigh the bucket and the biomass.
Right, and we can subtract the bucket too, right? So it could be wet, but generally we don't see fluctuations that high. Other guesses? It's normally the same unit. There's no reason why it would change over time, right? I guess. Or kind of just sporadically. So what happened actually is sometimes we have the scale here, and then the field worker would accidentally put a foot on it, right? And then you are just measuring the weight of a foot plus your bucket, right? So those things also happen. This is another one. So sometimes we have these flat plateau. Any idea what happened? Yeah, so they left it a long time. Sometimes they don't always follow the procedure of just immediately loading. Sometimes they may be busy with something else, so they put a bucket there first, and then they go and they come back. So we have those sometimes. And what about this one? Yeah. So well, the thing is that we have this stretch of no activity, so presumably the reactor actually ended, right? So this was actually just worker cleaning the machines, but didn't turn off the MRV system, so it's still reporting, right? So we kind of have to know when it stopped, right, and kind of correlate with the timestamp elsewhere to know when to cut things off, right? Finally, this one. Yeah, sensor failure, right? With, the skills don't last forever, right? So if you have a decentralized unit, that's one of the important factors. Sometimes thermocouples and sensors fail. How to replace them in a way that doesn't affect the quality of the data. So after all that, we came up with a kind of a setup, or at least a first draft of the setup to both onboard community partners in SOPs and train them, and also calibrate the sensors and documenting it in a way, and setting up the accounts, and then kind of set up the different aspects where we test the feedstock, the production end use, machine ops, invoices, receipts, and flue gas, right, which is a lot of stuff, and validation of that. For example, that's not just in terms of the biochar sampling, but also checking the data to make sure that whatever is being reported actually makes sense. Sometimes you may have duplicate entries, so how do you tell it's duplicate, and how can you remove that, right? So those are some of the things that happen at the validation stage. And finally, kind of uploading that and integrating that with the audit documents for Pure Earth or other registries. And we also were able to create our own kind of real-time dashboard where even from my laptop, I can control a reactor in India, 8,000 miles away, and mess around with it if I need to. And also see the production data, right? So every day in my email box, and those of our partners, they can get an email that says, to date, here's how much you've produced, right? And a lot of our clients actually appreciate having that level of visibility. So I'd also want to just touch base quickly on the Pure Earth. So we have also been working with them. Obviously, other registries have other provisions, but when it comes to fleet of reactors, the question is, can you certify them without having to certify each one of them? And the answer is yes, with some caveats. Right, so after working with them, and as Jason alluded to earlier, they have updated their methodology. That there's a mobile production facility defined as biochar production over multiple locations, and the fleet is several reactors within the same facility. And the word facility is important because each facility undergoes one audit, which means that if you add a new reactor, or if somebody in the same region with the same LCA buys a new reactor, they don't have to go through a new audit. They can be a part of the existing facility under certain circumstances, which makes it a lot easier for our end users to purchase new reactors because they don't have to go through that whole hurdle of the Pure Earth certification. It's defined as capacity expansion instead, which is the addition of new reactors progressively over time within the same facility. And that has a slightly lower bar to it than a de novo kind of a facility audit. So lesson learned for us is really listen and observe, right? A lot of our end users give us what they want to see out of MRV rather than us prescribing it. And the second is really start manually before we automate the process so that we don't spend a lot of effort doing things that's not needed. And the third is that we try to generalize so that we can have a portable MRV procedure, but we also realize that it still needs to be contextualized to a certain extent within each community, and have redundancy so that we can check for errors and other data. And finally is to be really proactive and persistent because a lot of those changes with methodologies take at least 1 or 2 years. Thank you, and you can reach us here.